My name is Priyanka Jindal, and I'm a Principal Product Manager leading AWS Private 5G. And I'm co-presenting today's session with Brian Searcy, who's a Principal with Amazon Events Technology team at AWS and a customer of AWS Private 5G. In this session, I'm going to recap what is AWS Private 5G. We announced the service at reInvent last year and GA'd earlier in this year. So I'm going to cover why should you care about it, what is it, and why we built it. For some of you who may have attended my session last year or have been following the service, you may have heard some of this content before. But my goal today is to go a bit further in detailing out how we build the service. What does the architecture look like? How should you use it? And what can you do with it? And how our customers are using the service today for simplifying and deploying their own private mobile network. Today, organizations and businesses are more dependent than ever on high-performance, reliable connectivity. This includes your machine-to-machine communication workloads. For example, autonomous robots in a manufacturing site connecting to a navigation application running in the cloud, or for connecting sensors for tracking inventory in warehouses, or surveillance cameras on a shipping dock. It includes connecting human-to-application workloads. For example, tablets in the hands of workers at a construction site, or connecting kiosks or point-of-sale terminals at retail stores. All these emerging use cases require consistent, reliable connectivity. Today, most enterprises use wired network or enterprise Wi-Fi for their connectivity needs. But these systems weren't designed for these emerging use cases, for connecting all these things. Wired networks will give you the performance that you need, but they're expensive to deploy and upgrade. And more importantly, they don't always cover the needs of these use cases with devices on the go. Enterprise Wi-Fi is easy to set up and use, but customers run into challenges with it with respect to range, coverage, reliability. This is why the promise of private LTE and 5G networking is so exciting for enterprises. Private mobile networks gives customers dedicated network capacity for their exclusive and single enterprise use, which means customers don't have to share their network resources with users or devices outside their network or compete for any bandwidth. Mobile or cellular networks also offer seamless handover for the multiple access points that make up the network, which makes the technology appealing for customers who are looking to coverage large areas or for looking seamless mobility for areas that expand from indoors to outdoors with predictable performance. And private mobile networks are particularly appealing for customers in specific industries. For example, industries which have stringent security requirements or are looking for higher quality of service level for their networks because of the kind of workloads, the mission-critical workloads that they're looking to connect. So where can enterprises go from here? Well, designing, building, deploying, and operating private mobile networks today is hard. It's time-consuming, and it's complicated. Customers have to qualify multiple hardware and software vendors and their components. Each of these components have their own licensing and pricing models that scale differently. And many of these models charge customers for the number of devices they can connect. And that adds up quickly, because if you're looking to connect hundreds and thousands of these devices, then customers have to go through complex integration across these vendors and components. Often use the services of system integrators, because building these networks requires telecommunication expertise that most enterprises don't have, or they don't want to invest in it because it's not core to their business. This is why we built AWS Private 5G, so that customers can set up and scale their own private mobile network in days instead of months, without requiring any telecommunication expertise, without the pain of long planning cycles or complex integrations. Using this managed service, customers can set up and scale their own private mobile network within days instead of months. AWS Private 5G gives you distinct capabilities. It starts with AWS Private 5G being a managed service, which means that we give you all the required hardware and software that you need for your private mobile network operation. We have designed the service to work out of the box, which means we ensure the network is auto-configured when you power on the hardware at your location, and it's ready to go live in minutes, or maybe a few hours, depending upon the size of your network. By default, it works with shared spectrum in the US, so you don't need a spectrum license first to start using the service. There are no per-device charges. You pay for the network capacity that you need. That is the number of radio units that you need for the coverage of your network. And I'm very excited to share a new update that we released in November just before reInvent. Using this new capability, you can now scale your network anytime you need in GA. Earlier, when we had released the service in GA, you could start your network with a starter network and order one radio unit per site. Using this capability, you can order as many radio units you need for your network. So you could start with a couple radio units and then expand that existing site with more as you go. And with multiple radio units spanning your network site, you will get seamless mobility for the end devices connecting to your network from any location within the coverage area. While designing the service, one of our main tenets from the very beginning was focusing on simplicity. To take the complexity away from building private mobile networks so that customers could use it for anything spanning from corporate offices, campuses, factory floors, or warehouses. So the first thing that we invested in is to give customers a hassle-free, self-serve, API-driven experience to building your network, which means that you can come to the AWS Management Console or use APIs, and if you know what you need for your network, you can order the network that you need without having to talk to anyone. Second, we said that if AWS Private 5G has to really take the muck out of building a network, then AWS needs to be responsible for all the different components required for your network. This includes the hardware, the radio units, and the SIMs, and the network software for your operation. In a cellular network, radio units play the same functionality as Wi-Fi access points play in a traditional access network. They come in similar form factors, could be installed indoors or outdoors, could be mounted on a wall, ceiling, or a roof. And SIMs are the same tiny portable chip that you're very used to putting on your mobile phones. Then there is the network software, or mobile core, as commonly known in telecommunication industry. And that's really the brain of your network. It's responsible for many functions that make up your network, like authenticating the users or the devices and routing the data to its end destination. Then we have a built-in integration and a registration mechanism for your radio units to acquire the spectrum grant. So you use that, again, using the console or APIs to complete that job. And thirdly, like any AWS managed service, AWS is responsible for managing the software and hardware that we provide you as part of the service. And that applies to AWS Private 5G. So when we give you the private 5G hardware, we monitor it from the AWS region that it's connected to. And we monitor the network health and metrics, and we would automatically push the upgrades or the firmware upgrades as and when required. So let's go deeper into how you would use the service. There are 3 sets of AWS resources that you would see when you start using AWS Private 5G. A network site, and network resources that belong to the network or your site. So starting at the top is your network. It is a logical construct, and it's a collection of network sites and SIMs that span your network. It is a regional construct, which means that you select the AWS region that you want your network in. Underneath your network is your network site. And network site represents the physical location where you want to deploy your network. That is where you would physically install the radio units that you order for your network site. And it includes, so it's a collection of radio units and the corresponding network software that manage those radio units and your site. And then you have your network resources, which is your radio units and your SIMs. Radio units belong to your network site and require uplink connectivity to the AWS region. And then SIMs can span your network and will go in the end user equipment that you're looking to connect at your site. When you start using AWS Private 5G, ordering is the first concept that you would encounter. Before you can order, you will create your network and your network site. It's fairly straightforward to create them. Currently, AWS Private 5G is only available in the United States. What that means is the network site that you want to install your network has to be in the US for the service to work. Radio units at the site require uplink connectivity, so you want to make sure that the network site can support up to a 1 GB connection. The next step is for you to create your order and select your network size. And by network size, I really mean selecting the number of radio units that you would need for your coverage and capacity, and selecting the number of SIMs that you would need depending upon the number of devices you're looking to connect. So once you place your order, behind the scene, we would do the infrastructure provisioning, deploy the software, and configure it, provision the hardware before we ship it to you. At this point, we have built in a security guardrail, a good-to-have friction, if you will, into your experience. We require you to acknowledge that you are in possession of the hardware that is meant for your AWS account and your network site before you can complete the activation process upon receiving the hardware. It's all built into the API and console experience. So you acknowledge that you have received the hardware. At this point, you're ready to activate the site. You plug the radio units into the power, give it the internet connectivity, register the RUs to get the spectrum grant. And at this point, you're ready to start using the network, insert the SIMs into your end devices, and you're good to go. Customers have told us that deploying private mobile networks can take months. With the typical AWS Private 5G install, with a few RUs, you would be ready to go in about 2 to 3 hours. And if you're only connecting, let's say, a couple of RUs, it should take you less than 30 minutes. And most of that setup time is really actually registering the radio unit so that you accurately report its coordinates to acquire the spectrum grant. So here's a visual picture of how this will all come together. So on the right is the AWS Cloud, and AWS Private 5G control plane in the region. Let's say on the left is where you want to deploy your private mobile network. And you have selected your network site. So you can get started by ordering your network through the console or through APIs. Once we receive the order, we'll ship you the radio units and SIMs, which you are ready to acknowledge and activate. You power on the RUs, connect them to the internet. RUs come pre-configured for access to the service endpoints and the third-party spectrum access system, which is all in the region. You see those as white and yellow lines connecting to the service, all those uplinks. Once activated, you can put your SIMs into your end devices, and voila, ready to go. So far, I have discussed the features and capabilities that you get with AWS Private 5G. If you attended Peter's keynote on Monday, he talked about all the things that we do in building a service that's not visible to you, the operational excellence, the things that we do to make sure the service is available and reliable. At AWS, we say all things fail. It's part of having physical things. Over the years, we have collected lots and lots of data to build services that have prevention mechanisms. But at the end of the day, failures will still occur. So we spend a lot of time designing our services to account for that. With AWS Private 5G, it means asking questions like, how should I build my network that can withstand failures? How do I make sure my network is available even when there is a failure? With AWS Private 5G, as you've seen, there are two sets of components. There are components that are in the region, and then there are components that are located on your premises. So with AWS Private 5G, all the components in the region, we have designed them to be redundant. What that means is that we can independently isolate, replace, or restart those components if there is a failure. Then there is the radio units, which are on your premises. If there are issues with those radio units, we have the ability to remotely do configuration or firmware upgrades. You see that as the white service line, going from radio units to the RU management plane in the region to the service. And if we determine that there is a hardware failure, for some reason that you need a hardware replacement, then we'll provide you the replacement because it's built into the service cost. And thirdly, there could be failures because of the way, where, and how radio units are installed on your premises. This process of figuring out how many radio units do you need for your network site coverage, where should you place them, is referred to as radio frequency and network planning. And especially when you're looking to scale your network site, account for things like having spare and overlapping coverage, it becomes important that you proactively plan it. This is why AWS Private 5G is helping customers by building an ecosystem of partners that you could work with for this. And this is available through the AWS Marketplace today. Another top-of-mind question that we often hear from customers who are looking to start on their private mobile networking journey with AWS Private 5G, or who are considering their 5G technology or private LTE technology adoption, is about the security posture of the service. More broadly, at AWS, we say, when you think about security, it's not about identity-centric trust or network-centric trust. It's an and. And that applies to our approach with AWS Private 5G. So the first principle is identity-centric trust. And it's really fundamental to how the mobile or cellular technology operates. SIMs are what are used to uniquely identify, authenticate, and manage devices with the network. SIMs come with an identifier and security credentials burnt onto it, and that's what is used to authenticate it with the network. So if you trust and control who has the provisioned SIMs, you can control who has access to the network. What we have done uniquely with AWS Private 5G is to take that notion of identity-centric trust and extend its use case and utility further by integrating it with AWS Identity and Access Management Service, or the AWS IAM service. As many of you may be familiar with, AWS IAM gives you the ability to uniquely authenticate and authorize each API request. And with AWS Private 5G, SIMs are part of the service we offer, which means SIMs are provisioned as an AWS cloud resource or as an AWS IAM resource. What that means is you can set API access permissions by attaching IAM policies to it. So for example, you can define API access permission boundaries for who has access to the SIM resources and who can take actions on those resources, such as activate, or deactivate SIMs, which is part of the AWS Private 5G service experience. The second principle is network-centric trust. So we are using network-centric trust tools at AWS to augment your private 5G network security. For example, we are using Amazon Virtual Private Cloud, or Amazon VPC, to isolate each customer's network and their user data within AWS Private 5G. Taking it further, our vision really here is to take SIMs and identities and make them aware of network-centric controls to give you richer capabilities over time. For example, being able to give you policies that you can attach at logical boundaries for your SIMs in your private 5G network. So we're just getting started there. So here's a visual summary of how these principles look like with implementation with AWS Private 5G today. Starting with the SIMs on the left. SIMs are burned with security credentials and provisioned with your network before we ship them to you. And only your network in AWS Private 5G service has access to the security credentials for those SIMs. So the SIMs and the network will mutually authenticate each other before SIMs can join the network after you activate the site. Once authenticated, the data traffic is encrypted and integrity protected. This mutual authentication procedure between the SIMs and the network and the corresponding data encryption standards is what have evolved over multiple generations of cellular technology and are currently defined by 3GPP 5G specifications. And that's really what AWS Private 5G is implementing. Then on the right is private 5G radio units. And these are pre-configured for access to the service endpoints and your third-party spectrum access service. And for all these connections, we use certificate-based authentication with the service. And on top of the encryption that extends for all the communication from the SIMs to the network, AWS Private 5G also uses IPsec to secure all data from your radio units to the network and the service. So far, I've talked a lot about how do you use AWS Private 5G for all your connectivity needs. And as much as I love to talk about it, it's really a means to an end. The end being that customers are looking to connect their devices and data to their applications. So what environment are customers operating in that they are looking to connect their devices from? I've highlighted here two categories of use cases that we see commonly with customers who are using AWS Private 5G GA service today. The first is customers looking to extend coverage or achieve seamless mobility between indoor and outdoor spaces because the environments that they operate in doesn't really offer them a practical or a feasible option to use wired networks, and Wi-Fi hits its limits. For example, customers looking to use connectivity at airport tarmacs or construction sites or shipping yards. Not very conducive to the alternatives. The second category that we see customers using AWS Private 5G for are what I'm calling as seasonal networks. The customers are looking to take their network with them where they go. They're looking for the network to be able to adapt to their needs depending upon the event and the location they are in. This includes use cases as customers looking at deploying networks at events like these, graduation ceremony, even for natural disasters. And where do the customers want to send their data to? A commonality across these use cases that we see is that customers want to route their device traffic to the AWS service endpoints, or to their own application endpoints within their own subnet or VPC, or to third-party services. And AWS Private 5G is enabling all these customers with their workloads today. With that, I want to invite Brian Searcy to share his customer story and journey with AWS Private 5G.
Hey, Priyanka, thank you very much. Appreciate it. Good afternoon, everybody. I'm Brian Searcy. I'm a technical program manager on the event technology team here at AWS with marketing. Welcome to re:Invent. We hope you're enjoying it. My team is actually responsible for the majority of the technology that we use to put on this event. My background specifically is in the networking side, so Wi-Fi, wired networks, all the things that we set up around you and bring you all the connectivity. I've been in this industry for about 12 years now. This is my 9th re:Invent. So we've been around all kinds of interesting and future-facing use cases, and we're always trying to, push the limits of our existing network technologies, wireless technologies, Wi-Fi, obviously, in particular. So we're really excited about the potential of some of these private 5G applications. There are a number of use cases, frankly, where, we've hit the limits with Wi-Fi, or we're worried about congestion, we're worried about privacy, we're worried about overlapping spectrum and the limitations that comes in. Particularly if you have been to some of our tougher environments here at the event, the expo hall registration, you'll know that there's a lot of use cases where we have hundreds and thousands of devices competing RF spectrum. How do you ensure reliability? How do you ensure data delivery in sizes this big, right? So one of the big weaknesses, frankly, of Wi-Fi and any shared spectrum is that no matter what we do, we can't always control who else is using the spectrum, who else is on the spectrum. It's very difficult, for example, to guarantee video applications in an environment like that. It's very difficult to ensure 100% there won't be any interference. Another use case that we commonly come up with, we like to do registration, or we like to do some of the activities or events in challenging environments for wireless. I don't know if any of you have ever been to our events in New York, but the Javits Center is right on the river. It's entirely glass cased. It's in the middle of Manhattan. There are airplanes and boats on the river and all kinds of RF interference. And from the steps of the center, you can see the Wi-Fi from half the hotels in the area around there. So all these challenging locations, but of course it looks great. And we want to set up, we want to have registration, we want to allow you to use your devices, we want to allow security teams, video teams to set up and use the network. If you came through the airport and picked up your badge there this week, you'll know that setting up public Wi-Fi networks in airports and in other places where you can't control who's coming in and what they're doing can be a very fraught experience. So these are some of the areas that we really want to look at for private 5G usage today and into the future. So a couple of just to summarize where Wi-Fi, we hit the sharp edges or we find challenges. Shared username and passwords, right? I don't have to worry about sharing a SIM card, but I do have to worry if I'm setting out a password, trying to make a private Wi-Fi network, somebody could share that. We can't always ensure that nobody else has access to that network. Indoor to outdoor transitions, especially in Las Vegas, the air here is very dry. RF propagation is very easy. It's very difficult to, as you leave the inside of a building and move into the outdoor space, ensure reliable Wi-Fi, frankly. And then, of course, obviously, there is no airtime fairness in Wi-Fi. There is no ability to ensure that you have guaranteed spectrum. So somebody else can always turn up. They can always put a router with, 160 megahertz channel and step on half the radios in the expo hall, which happens every day at re:Invent. So how do we get around these limitations? How do we set up networks over this that aren't suffering from some of these challenges? So just as Priyanka talked about, all the advantages here with private 5G, SIM cards, physical access. I can hand somebody a card for their device. I know that they have it in the device. If I see that SIM card show up in a different device, I can deactivate it. I don't have to worry about somebody sharing passwords. I don't have to worry about who else is on this network. It's very secure in that way. On the agility side, I order it in the console. The box shows up at my door in a day or two. I plug the radio in, certify it. We can be up and running in just a few minutes. The common event use case here is registration networks or any kind of customer engagements outdoors. We don't have a lot of time to show up weeks in advance, to set up networks, to run cables, to do everything that you might do in your more traditional enterprise deployments, frankly. So the fact that this is plug and play and that I can have it in a couple days makes life a whole lot easier. I set everything up, put it in a Pelican case, ship it to the event site, and I know the team there can set it up and be up and running in just a few minutes. It's also pretty adaptable. We can scale up and down. We can go to multiple radio units. I can add SIM cards. If I have a smaller event, next week or a couple weeks later, hey, I can just ship half of it out. I don't have to worry about trying to, boil the ocean or have a giant inventory of this that I'm, holding any time. It's really just point in time. What do I need to design for for my current needs that day? And we already talked about, dedicated bandwidth, dedicated spectrum. I'm not concerned about what other people are doing. I can promise the presenter on stage or the video team that's broadcasting or the security team that needs surveillance camera in a critical area that, yeah, this is up and running and we know it's going to work for you. So real quick, we'll go through the ordering process. For the network that we built here at reInvent, we ordered this a couple weeks ago. We had it shipped out here to our staging warehouse in Las Vegas. We prepped everything within a couple days. So the ordering process itself takes about 5 minutes. As Priyanka mentioned, we go through, choose your network, define your site, you're off and running, you choose your region. Configure your plan. This is the critical piece, right? How many radio units do you want? How many SIM cards do you want? You can start with whatever you need. You can update it later. You can always grow. So you're not locked in anything from the beginning. On to the next one. So here, once we've got our order placed, we're waiting for it to come to us. It's going to take a couple days. We have this acknowledge up at the top right. Nobody else can start to provision this order. Nobody else can activate it until I have everything in hand and I choose to go forward. So we've got that chain of custody. At the bottom there, you can see this is all the radio units that have been assigned to us that are in the mail. So that's the acknowledgement. I've got my box. I've got my order. The tracking code matches. All the inventory matches. There's our radio. Let's go ahead and get set up. So once I've got it, the next thing is that we have to enter the coordinates. So you need a CPI to do this. This is a pretty easy thing to acquire. Anybody who's got a little bit of expertise in Wi-Fi or cellular networks and radio networks, it takes an afternoon. You study, you take the class. It's a quick certification process. And then all I have to do is add latitude, longitude, elevation, height. We can certify multiple radios, certificate process to go in with it. And within a few minutes of me opening the box, plugging the radio in, giving it power and network, we've registered it with the SAS, and wait for the pretty lights to turn green, right? This is 10-minute process. Once we're on the event site, once we're in a warehouse, once we're any other place we need to go. It's my favorite thing about this, frankly, because usually we're shipping trucks worth of equipment, we're waiting on backhaul, we're waiting on people to set up, we're waiting on stages to be set, we're waiting on everything that goes in one of these rooms. And it's really easy for me to just drop a radio, plug it in, you guys are off and running. And we'll just do a quick video here. This is showing what we went through when we were staging the network we built here. So that you'll see the warehouse, you'll see us getting set up, mounting some of the radio units. You'll see a little bit of some of the roaming and the handover testing that we did, going between a radio unit in one part of the hall to a radio unit in the other part of the hall. And the other nice thing about this is the coverage area is so wide that what I usually have to take 5, 6, 10 wireless access points for, I can put one radio on one side of the warehouse, one on the other, and I've covered the entire thing. Hopefully you caught the hand over there in the middle when we changed rooms. So I've talked a lot about what we've done in the past with this, some of the challenges that we have in the indoor spaces, what we've done. A quick story about what we actually built here at reInvent for the first time this year. So we wanted to take this and push this kind of to the limits of what we can do today. So we've got this set up in the expo hall. We've got a few radios in there, but we wanted to build this network to come outside a little bit too. So we installed some other radios. We have them actually here in Caesars Forum. We have coverage from the expo hall out through the bridge, out through this building, and we've wrapped it all through this building and outside to the tent in the front where you have some of the other activations at. So we've got this entire half of the reInvent campus at this point where we can plug a device in. I can roam through some of the busiest areas of the event, and I don't have to worry about what anybody else is doing. I don't have to worry how many people are in the expo hall right now, how many rogue devices do we have set up. I can sit in the middle of the busiest parts of the event if I need to, and guarantee my coverage. So that was a great experiment for us. It was a lot of fun. Some of the future things that we're looking to do with this in the year to come, one of the most interesting propositions that I was ever given by part of the events team here was, hey, what if we had a sponsor activation in the high roller? Could we put a wireless access point in every single one of those pods? Could we give everybody, convention Wi-Fi? Could we give them the AWS reInvent network experience in the high roller? This was about 3 years ago. The answer was absolutely not. Are you crazy? The answer today is actually, maybe we could do that. We have some other interesting environments where we deploy. What if we go into outdoor areas where we're doing events on a golf course or a country club? How do we put up our own private, secure bubble of network that we can guarantee our security stakeholders can handle? We can guarantee their radio coverage. We can guarantee surveillance cameras, right? We can guarantee that no matter where you are on a campus the size of reInvent even, that if you're within the area, if you're indoors, if you're outdoors, we can guarantee that level of coverage, that level of service. We're not worried about deploying hundreds of access points and worrying about interference and all the other problems that come with some of these really, really large and scaling Wi-Fi networks. One of the other cool use cases that we're looking at, you saw the warehouse where we do a lot of our testing and staging and packing, and we ship our equipment out to all the other events. How can we use this service? How can we get a little bit smarter about our inventory and our tracking? How can we build on top of that and do some of the cool industrial, IoT things that people are doing here? How can we share that to different sites? How can we take that to places where maybe we don't have our own network? So all these things that Private 5G opens up for us that we're really looking to try in the future. All right, and with that, back to Priyanka.
Thank you, Brian.
There's your clicker.
If you're looking to explore and are curious about AWS Private 5G further, I wanted to share a few additional resources that you have available at reInvent. We have a session in the demo theater within AWS Village in Expo Hall tomorrow morning. It's a demo theater session, and one of the topics that we are looking to cover over there that we hear from customers is what kind of coverage can the radio units that you're offering with the service provide for us? So we have a lot of data to share from our customer deployments and proof of concepts across both indoor and outdoor deployments that we would share in this session tomorrow. So if you are curious about those data points, you can check that out. We also are present in AWS Hybrid Kiosk, where we have a live demo using AWS Private 5G in the Expo Hall. And you could also stop by and discuss and really ask any questions. You can also visit our website. That's a picture of me with Dave Brown, who's the VP of EC2. And this was taken at the time when we were testing and deploying AWS Private 5G at one of the Amazon facility here in Seattle. And you would see more about that on our website in the coming week. Thank you.